As you work through your A-level maths course, you're going to find increasingly, especially as you get further and further through, that most of your success depends on the work you put in between lessons. So it doesn't matter how well something makes sense when you first have it explained to you, or when you're working on a question alongside somebody else who's also working to understand it. What really matters is when you're on your own and you don't have anything to help you, and you're not looking at the answers online, and you're not talking to friends, are you still able to solve the problems? We're going to talk about a few ways that you can train your brain to do that effectively, and a few of the common pitfalls that people fall into, especially these days. This should be particularly relevant for year 12s who are just finishing up their first year and are about to embark on their second year, especially if they're trying to make a plan for the summer and figure out what they want to do with their time before they come back in September to be as ready as possible for year 13. To begin with, it's the fundamentals. We always come back to these. If you're struggling with the basics of rearranging an algebraic expression, or you continually fall into particular traps, like when you square a bracket, you only square the first and last terms instead of finding the middle terms, or if there are other common pitfalls that you trip up with, fractions, indices, that kind of thing. A really nice starting point is things like the mixed exercises in the textbook, particularly for those early chapters, and the skills check documents that I'll get to a little bit later. There's also a key results quiz that you can work on that just pinpoints basic results that you should know for each chapter. Things, some of which you might have known or known about before year 12. A lot of them will have been new, so they're things that you might have learned but you've not properly consolidated yet. Essentially, to get a foothold in a question, you need certain prerequisites. So there's no point bashing through past paper after past paper and struggling to pick up any marks unless and until you've got the basics down. So if this is what it takes, you go back to particularly chapter 1 and chapter 2 from your Edexcel book. We're looking at indices, surds, rearranging algebraic expressions, working with quadratics. You should find that it's easier to soak up that stuff and to get to grips with it now, because you've seen in so many of the later topics in trigonometry and calculus over and over again, these same skills keep coming back around. So your brain now knows that there's a motivation for learning them. Next, it's about marks per minute. So we're working towards, particularly those of you at the top end or the ones wanting to get towards the higher grades, you want to think about how you're going to translate the maths that you know and the problem solving that you're starting to be good at into maths under timed conditions. And it is different and it's not ideal. Personally, I don't think that a timed assessment where everybody's rushing to try to finish is the most effective way to assess mathematicians and problem solvers. I would always rather have somebody who gets it right and knows they've got it right than somebody who's fast and mostly correct. But that's by the by. This is how things are assessed, and it's not just in maths. You'll be assessed in timed conditions and in stressful scenarios throughout your life. So learning to work within the confines of the limitations of that assessment will be important. Marks per minute is a way of looking at a paper that shifts the focus from I need to get this question correct and then move on to where am I going to pick up the maximum number of marks for every minute that I'm investing in this paper. And if it's not happening on question 7, then maybe put a pause on question 7, move on, have a look at questions 8, 9, 10, see if you can find somewhere where you think, okay, there's a few quick marks I can get here, or I definitely recognize this topic. And it's not just about topic by topic, but within a question, you might find that you've done most of the work to complete something. You just can't quite get it written in the correct form that they've asked you for. I've seen a number of questions where there'll be 4 or 5 marks, and it will take me a minute or two to get the first 4 marks, and then I'll be sat there crunching through line after line of messy algebra and probably making mistakes for 3 or 4 minutes before I get that final mark. It's really not worth it if there are other questions that you could be spending that time picking up marks on. And this is even true with the early questions, the questions where you know what you're doing. If you complete a 4-mark question in 2 minutes and you're feeling smug and you jump ahead to the next question, there's a decent chance you've made a silly mistake on the first question. Silly mistakes creep in. So get used to being careful enough and slow enough with the early questions that you can be confident you've picked up the marks that you deserve, and you're not rushing ahead to get stuck on a tricky problem when you haven't fully made the most of the question that you can answer. One important fact that you've probably discovered if you've done any mock exams is that doing an exam in exam conditions often feels very, very different to doing past papers at home or working on exam questions in class or with a friend. a good way to build that confidence working under pressure is to gradually increase the level of stress that you're under when you're doing a past paper. You can do this in a few ways, but making sure your environment is as similar to an exam environment as possible makes a big difference. So maybe if you normally work at your desk up in your room, you find a quiet time of day and you go and move your stuff down to the dining room where you're sat in an unfamiliar place for sitting and doing maths. And perhaps you make it so you're not allowed to have your headphones in while you're doing your past paper. You're sat in silence, your phone's in another room, you've got a clock in front of you. You've made it so that it's going to be awkward to do anything but sit and do the paper. And you give yourself a strict time limit. It might be a good way of adding stress and pressure, making it feel like it counts, is to tell somebody, a parent or a friend or your teacher, I'm going to do this paper on this date, ask me how it went. And then you know that the results matter, at least in the sense that you're going to tell someone what grade you got. You're going to show them the exam question that you tried. So it now matters, rather than just being a question you did for yourself. It's a question you did in order to tell your mum what grade you got on that paper. And no matter how supportive and encouraging she might be, the fact that you've got to tell her will add a little bit of stress, which might help you to see what it's like doing maths under pressure. Past paper practice is basically the whole ball game when it comes to preparing well for A levels, because you will be assessed 100% by exam. So if all you're doing is using the textbook and working with integral maths and watching videos about things and trying questions, you will have only a limited understanding of how to approach exam style questions. So the student exam questions that are provided for you, I'll remind you of the links for those, where it's exam questions by topic. They're really helpful when you're working on a particular topic. You've decided to home in on quadratics or on trigonometry, and you want to get a volume of questions on that topic to get a feel for how you're assessed on that topic. That can be really effective. But then when you get more confident, when you've covered more content, look at whole papers. And a year 12 student can look at any of the AS papers, and they'll be good practice and good consolidation of year 12 content. And you can look at A2 papers. Just be a little bit aware that most of the questions you won't be able to access very well. But that said, about a third of the questions you will. About a third of the questions are questions that a year 12 student can access. Often up to 40% of the marks will be marks that you could get just with year 12 knowledge in theory. And up to another third are questions on topics that you might be able to have a look through usefully and say, there's things in here that I might be able to make sense of. Given enough time looking at the formula book, I might be able to work out what's going on here. So if you're starting to run out of past papers and you've tried the ones online and crash maths and whatnot, maybe looking at some A-level papers would be a useful next step. The next and possibly the most important thing I want to say is being stuck. This has become something that's harder for students to do these days because of the environment you're in. You've got all of these wonderful advantages over somebody who was brought up in, even 10 or 20 years ago that people didn't have. It's easier now than ever it was before to find a mark scheme for a question. In fact, it's too easy to get solutions from an AI, to the extent where people don't bother even looking at mark schemes. You'll just take a photo of your question and straight away ChatGPT or Gemini will splurt out for you a complete solution to your question. 9 times out of 10, that's not what you want. If the question needs doing but you're not doing it, it's the equivalent of getting a big strong friend to lift the weights for you at the gym. What's the point in going to the gym if all you're going to do is watch a strong person pick up heavy things? So what you want to do is train yourself, no matter how uncomfortable it might feel, to be stuck. That means you work the problem. When you realize and recognize you're stuck, I've been told in the past, and I've found it helpful despite how weird it sounds, write down the words I'm stuck. And that starts, if you build that habit, starts to trigger your brain to say, I'm no longer looking for what I should do with this question. I'm just looking for anything that I can do with this question. What possible things might be useful? Let me write down what I know about the topic. Let me start highlighting the information I've been provided in the question. Let me look at what's being asked of me, and I'm going to start to mess around and see if I can make anything stick. If you know what to do, then just casting around for random things is a bad strategy. But if you don't know what to do, it's a much better strategy than doing nothing at all. So set your stall out, say this might feel uncomfortable because I'm normally used to knowing what I'm doing and now I don't know what I'm doing, but be prepared to spend the time being stuck. Do not give up too soon. If you're doing a timed exam paper and you need to move on from a question because that's part of what you're training yourself, fair enough, but make a point to go back, and before you look at solutions, you spend some time afterwards just on that question. What could I have done if I had another 20-30 minutes on just question 9? Let me have a go. And all I'm allowed is a formula book and a calculator and a pen and paper and whatever determination I have left. A really useful tip is to wait a certain amount of time. If you can, 24 hours. If you can't, 20 minutes. Give yourself a plausible target that you can actually meet. And do not check a mark scheme. Do not ask AI. Do not ask for hints and suggestions from other people until you've had time to be stuck, to go away and to come back to the question again for a second helping, and work at being stuck on problems. You'll be amazed how much effect this has on your overall resilience, because the more you work on a problem, the more your brain gets comfortable with the process of not knowing what to do, and you will find things that you can do when you're stuck. If you train your brain that when you can't do a question, you give up or you look at a mark scheme, those strategies don't work as soon as you're in an exam. These are habits that you want to build in so they become automatic processes. Everybody says it, from the army to the firefighters, everybody. If you want to do well, you train in the way that you want to perform in practice. You don't rise to the occasion, no matter how much we imagine we might. You sink to the level of your training. So whatever habits you've been building by doing them day in, day out, that's what you're going to do when the rubber hits the road. A few things you can do when you're stuck. Being stuck, even if you're sitting there staring at the page and you can't write anything down, that's still useful time. You're priming your brain to recognize that the knowledge you don't have is important knowledge. The understanding you don't yet have is worth your brain hanging on to, so that when you eventually discover it, it's going to stick. You reread the question, okay? Just go through it again, read it more slowly. It didn't go in the first time. There were things that didn't click, it didn't make sense. Figure out which words you don't understand. It's like, okay, there's a definition in here that I need. It's talking about stationary points and I can't remember what that means. Or it's referring to a tangent. Or it's talking about making this the maximum value it can be. There's subtleties that to a trained eye will immediately scream, differentiate the thing. But if you're not familiar with it, then identify those words. And then even if you can't figure them out later, you can look them up and go, oh, that's what this was telling me. That's what I need to remember for next time. Taking a break is really powerful. Even in an exam, you can take a break. You can't get up, walk around the room and get yourself a quick can of Coke. But what you can do is move on to a different question. Maybe save yourself a nice circles question that you recognized early on. You think, yeah, that looks pretty standard. I'll go to that and I'll switch off some of my higher order problem solving while I complete the square and identify a center and a radius. Then I'll come back to question 9. I'll read it again with fresh eyes. It's surprising how often for me that works. I'll try a question and again, and it's like, no, I need a break. 5 minutes later, I come back, try it again, and almost immediately I discover the thing that I misread the first time, or the mistake that I kept making, because once your brain's made a mistake, it wants to make the same mistake again. A brief break, even if it's a brief break, will give your brain a chance to sort of clear the cache, get rid of the messy working memory and the stress, and let you start it again fresh. When you need to, when you're not in an exam scenario, review your course notes. You can look back at the notes you've made for different topics, and this is where you'll find if you don't have good notes for a topic, you recognize that when you're doing an exam question, and you go back and you make some. You make the notes based on what you needed for the questions, and they might feel more relevant and useful that way anyway. And if you need to, get a hint. You can do this from a friend, from a teacher, from a sibling that knows the subject, or you'd be surprised how beneficial it is just to talk to someone who doesn't know anything about your subject and get them to just ask you questions. And the questions will be things like, well, what do you know? What maths might help you here? What information are you given? What do you need? What's the question asking for? What format would it take? And then you can start making a question plan. How are you going to get from what you know to what you want? And those are questions that once you learn, you can ask yourself those questions. 9 times out of 10, clarifying your starting points and ending points will give you a beginning. You can then make a start, and once you make a start, you can see more things to do. It's like gradually filling in a jigsaw puzzle. It becomes easier and easier because you have more and more pieces in place, and it's clearer and clearer what the missing pieces would hold. Next, a few quick tips for resources. You might remember we've got links to the Chalkface resources, past papers that you can quickly and easily find along with their mark schemes, and then exam questions by topic, where there's a whole bunch of questions pulled from recent exams and sample papers and so on, that you can just do a series of questions on a specific topic. The revision resources are basically a regurgitation of some of the links that you've already got from me if you're on my course, and the flashcards is key results that you can use as a sort of digital flashcards thing. The code might be a little clunky, so hopefully it works on your device without breaking everything. I have improved it recently, so we'll see if things work the way they're supposed to. Problem solving. We've talked a bit about what do you know, what do you want. Here's a little bit more detail here. I'm not going to talk through everything right now, but if you wanted to pause, take a screenshot, there's additional details here about what that actually looks like. What do I know? Reading through a question, identifying the key things, and that might be different for different questions, but you can build a sort of a habit for a particular type of question. When you're doing optimization, it's always going to have a roughly similar structure, so you can identify the pieces you're looking for. If it's mechanics, part of what you do at the very beginning to figure things out is drawing your force diagram, making sense of the setup in order to make the process quicker and simpler. Most of the time, the actual process of doing the maths, especially for something like mechanics, is going to be much, much simpler than the process of setting up and figuring out what the question wants from you. In terms of how you write down a question, there are all sorts of subtle things that make a big difference. And I feel a little bit hypocritical talking about layout because part of that does come down to how neatly you write. And my handwriting is pretty atrocious. But I've discovered that despite not being able to write very legibly, I can still write in a clear and understandable way if I lay out the work carefully. If I make sure that I'm labeling the key things. So if there's a way of saying what I'm doing, like finding stationary points, identifying critical values, whatever it might be, I can just jot that down. And that reminds me when I look back through the notes exactly what I was doing. Simple things like leaving a line space between one line and the next. When my son does a bit of writing and he knows he's going to have some spelling mistakes to fix, he just leaves a gap between every line, and then whichever words need correcting, he can correct them in the space underneath. Now, he's not going to stop making mistakes because he's a human. I haven't stopped making mistakes because I'm also human. I'm glancing to the side, I see a line of maths that I wrote and I've had to cross it out because it was wrong, and I've ended up having to write something different. It's going to continue to happen. So instead of pretending that you'll somehow reach some magical stage where you no longer make errors, start to work with the person that you are, the person that occasionally makes mistakes. And one of the simplest ways is to give yourself some gaps so that when you're fixing a mistake, you don't have to do some messy scribble by the side of the page where there's no room. You can literally write in the extra line, or you can correct and replace a line because there's space there already for you. It's amazing how much of a difference it makes. I like to reserve part of the page as well for my notes. So work vertically down one side of the page, and then maybe use the right hand side or the top left or something of your page, whichever bit you don't normally use for the rest of your flow, use that for the little scribbly bits. You've expanded a bracket but you did it in one step instead of two, and you want to double check you've done it right. Go up to the top right where it's not going to interrupt the flow of your question and give it another try there. Accuracy is important, but it's not something you can just say, well, try to be more accurate. How do you be more accurate? Well, part of it is learning which processes you can afford to do in 3 steps rather than 5, and which ones you need to be careful and make sure you take 2 steps instead of 1. So learning where you make your mistakes. Is it in expanding brackets? Do you always miss those middle terms? Is it when you got lots of negatives? Is it when you have lots of brackets around and you can't make sense of which one's which? If you find yourself in a situation where you typically make mistakes, slow it down, include extra steps to work out each piece, and convince yourself you've done it right. But ultimately, mistakes creep in. So what do? We find multiple ways to ensure that the answer is correct. Sometimes that means working out in 2 different ways. I was going around the factory at CERN the other day, and they've got an experiment trying to figure out what on earth happens to anti-hydrogen when you drop it or something. And no one else is doing that experiment, so there's no way for them to check their answers. So they created a whole different experiment just a few meters away that is trying to test the same thing, but in a different way. That way, if they get the same results, then the 2 experiments corroborate one another. That's what you can do sometimes with maths. You've worked it out one way and you want to see if it works, try working it out a different way. Now that's easier said than done sometimes. There's often just one clear and obvious sensible way to go, but maybe finding the vertex of a quadratic, you can complete the square, you can differentiate, you can plug it in the calculator, you can find the roots and then go halfway. So there's a few ways to check in a lot of those cases, but often it's just a case of verification. That means if you've already got an answer, it's a whole lot easier to check the answer than it is to find it in the first place. You found the equation of a line, well, draw it on the graph and see if it's sensible. Does it fit with the diagram you've been given? Do you have a positive gradient, and is the line sloping upwards, etc., etc. Structure is to do with planning out an answer mostly. So if there's a big multi-part problem, if you can put some bullet points down that explain what you're going to do when before you start, it helps your brain focus on just the piece you're doing before you move on. Explanation can be helpful if you're writing out a model question for yourself. So I wouldn't recommend you have a whole load of notes and description and this is why I did this in an exam paper, because time is kind of important. You don't want to be squandering it on explaining to the examiner how quadratics work. But if you're writing a model solution for yourself as part of your revision, it can be really useful to write down in words why you're doing what you're doing. And then even in an exam, those words, those explanations that you've built the habit of writing down, they'll be in your head. And you'll be saying to yourself, oh, I'm multiplying the top and bottom both by root 3 so that I can get rid of the root 3 from the bottom. And you'll find that as you say things, some of them don't make sense, but you only notice when you say it to yourself. So that explanation habit can be really helpful. And last, but by no means least, review. I cannot tell you how many times I think the most common mistake I make is racing through a question that I know how to do and then moving on straight away. So many times that results in me making some daft little mistake somewhere and never knowing that I've made that mistake. So do a last little check, just like as you leave the house, you pat your pocket to make sure you got your phone and your keys. This is the equivalent of that. So just double check that the dog's inside the house and that you've locked up and that, you've brought your bicycle helmet. This is basically saying to yourself, have I read the question properly? Have I answered what they asked me to answer? Have I answered all the parts, D, I, etc.? Have you got all the bits that the question was asking for? And are they in the same format that the question asked for? Because so often you do almost all the work and then only pick up 3/4 of the marks. You'll miss a mark or two at the end just because you didn't round properly or because you'd worked out T but they needed X and it was just one little extra substitution step and you didn't do it because you didn't read the question again. They're really annoying things to get wrong and we do it all the time. So build that as a habit. Maybe even put a little box as soon as you see an exam question, put a little box in the right hand corner of the page and don't tick it until you've finished and read the question. And then when you know you've done it, you can give it a tick. Use of technology is worth a quick shout. Technology is fantastic. It does all sorts of special things for you. And these days, even more weird and wonderful than just calculating devices. Visualizing graphs is great, and GeoGebra does a great job of that, better than fancy, expensive graphical calculators, to be honest. The advantage of a graphical calculator, if you've got one, is that you can take it into the exam. The advantage of GeoGebra or Desmos or Wolfram Alpha is that you can get it on your phone right there and then and type in the equation of curves really easily. You can visualize what's going on more easily than you can if you're just working by hand. AI is a different beast entirely, and whatever I write or say about AI is going to be different in a couple of weeks' time, but it's getting incredibly good at doing maths these days. So although you can't trust it completely, for the typical A-level questions that you'll be asking, it's really good at doing the maths properly for the most part. It's also very good at the back and forth. If you're trying to make sense of something and you're asking it questions, it can answer them. So if there's a concept you're just not getting your head wrapped around and your teacher hasn't explained it to you in a way that makes sense yet, or the people who've said, oh, you just do this, and you say, but why? And you're like, that's just what you do. That's not a good enough explanation. You shouldn't be satisfied with it. Maybe try one of these things and talk to it back and forth. If nothing else, it'll be a place to bounce your ideas and your thinking off, and it'll help you to understand something. But do not use it as an alternative to building resilience with problem solving. If you let the computer solve your problems too soon, then you're not going to learn how to solve them for yourself, and you're basically giving up on the opportunity to learn how to be resilient, how to solve problems, how to be a mathematician. Don't let the computer take that away from you. The topic overview document is going to be a really helpful thing for you to use if you're planning out your independent working time. You want to make sure you're hitting all the key topics. I've just put the first few topics up here as an example, but also because they're probably the most important bits. We often skip through them quite quickly and then get onto the meaty, interesting stuff that comes later. But these underpin just about everything else. I reckon about half the questions that you'll see in your final A-level maths exam involve quadratics or the skills of quadratics in some way, shape, or form. They crop up everywhere. Equations and inequalities is huge. And algebraic expressions, working with index laws in particular, and being comfortable rearranging and manipulating expressions, factorizing things, expanding things, all that stuff, really important. What I've got on here is a little bit of a summary of what the topics involve. So you might be able to use that to do like a checklist and say, yeah, I'm happy with that. I've practiced this. I'm confident with this. You can use it to work through the book, the subtopics with the 2.2, 2.3. They will help guide you to particular examples in the textbook or exercises of questions that are specifically designed to assess that particular thing. And then the details of the learning objectives will help you understand what it means when it says inequalities on graphs. What does that mean? What do I actually have to do? You've got to be able to interpret them and perhaps represent them as well. On the right, you'll see we've got suggested mixed exercise questions. That's from the Edexcel textbook. So if you don't like the idea of doing every single mixed exercise question, which is not a bad idea, but if the options are you think you have to do all of them and therefore you do none of them, or you decide to do a few is better than none. If all you can do is say it's too daunting to do 2 hours a day, then do 15 minutes a day. Start small, start with a target you can actually reach. And maybe you just say, I'm going to do one of the mixed exercise questions from the first 3 chapters, and then I'm going to see where I go from there. Once you make a start, once you begin, very often you'll find it's easier to continue and to persevere. It's just the starting that can be difficult. So these are some questions I've picked out that give a good cross-section of the topics involved in a particular chapter. And there's a link in that document as well if you want to go straight to the mixed exam questions on a particular topic. Just briefly, this is the skills check to give you an idea of how to use this because it can be used in different ways. The way I like to do this is to have it as a no more than 20-minute task. For a lot of topics, it'll be much quicker than that. Depends how confident you are. And you can come back to them and use them again and again. The first time you do it, you're probably going to be doing part A of each question. So you just do 5 questions. You've done level A, which is slightly easier and simpler than levels B and C. And the first goal you're trying to get to is, can you correctly answer the questions? And if you're starting to get the questions correct, then the next goal is, how long is it taking you? Because as you build fluency, it's not just about can you factorize it given enough time and patience, but can you quickly and easily identify the factors? Bear in mind for quadratics, a bit of a weird one because the calculator will help you. But if you rely too heavily on the calculator, you will miss the understanding that goes behind just about every question that involves quadratics. So it's no good being able to let the calculator solve a quadratic for you if you've solved the wrong quadratic, or if you were supposed to be finding a stationary point and you've just found the roots. So you might find the skills check helpful. As you get onto year 13 content, particularly, more of the skills check documents will be relevant to you, but there's some for pure maths and there's some for applied maths as well. So it kind of covers the whole spectrum.